How's it going, guys? Welcome to another episode of Rojo's Reasoning, episode 4. So for today's problem, we are looking at a transmission electron microscope, and we're looking for the resolution limit on that electron. So the only thing that we know that's given to us is that the microscope is a 3 mega, or dealing with the microscope, it's a 3 megavolt electron, and that's it. But we know that when we want to find the resolution limit, that's the same thing as the wavelength. So for that equation, we want our wavelength to be equal to Planck's constant over our momentum. And this will take a little bit of manipulating to kind of get what we want. But let's get started, shall we? So we know that momentum can also be written as the square root of 2 times the mass times k. And so lambda is equal to h over the square root of 2 times the mass times k. And to kind of help us out a little bit, we also want to multiply by 1 or the speed of light on both sides. So this will end up being hc over 2, and then to kind of make it equal to 1 or equal, just to see here, we need to square our speed of light. So it's actually mc squared times k, because the square root of a squared number is that number. And so now it's just a matter of just plugging and chugging. So we know that our mass of an electron times the speed of light squared is 511. But we also want this to be in electron volts, just because we know that it's given to us in just megavolts, but it's of an electron. So we want to rewrite that as 3 times 10 to the 6 electron volts. Mega is 6. So that's kind of why we arranged the equation this way, with having the mass times the speed of light, because we also want it in EVs. So now that we have our equation, this is just essentially a matter of just plugging and chugging. So we know that HC is equal to 1240. I think, what is it, EV? I can't remember the unit, but it's EV something. So essentially it is 1240 all over the square root of 2 times, we want to convert our mass times the speed of light also into the same kind of units, EVs. So this will be 5.11 times 10 to the 6, and our k is up top here, which is our 3 times 10 to the 6 electron volts. And so when we do that, we end up getting 0.0007008 times 10, or no, sorry, there's no times 10, nanometers. So this is also kind of it was a similar example on page 169 something or other. Except instead of having the 3 megavolts, I think it was 50 electron volts. So that's kind of where we used, or rather, that's how we got this equation, was from that one. But instead of having our 50 electron volts, we had our 3 mega electron volts. So that'll do it for us. Hope that helped you guys out, and we'll see you on the next one.